Functions w and z are both linear functions of x. Which statements comparing the functions are true? So let's go through each statement and see if it's true or false. The first statement says that the slope of function w is greater than the slope of function z. So let's find the slopes of both and compare them. To find the slope of function w, we're given a graph, so we can use the rise over run of the graph to find the slope. If I go from point to point on the graph, I'm going up 1, right 2, up 1, right 2, up 1, right 2. So the slope would be up 1, right 2, or 1/2. Now for the table, we have two choices of finding the slope. We can pick two ordered pairs from the table and use the slope formula, or we can compare the change in y over the change in x. So for slope, I'm going to compare the change in y over the change in x. The change in y, we're going from negative 2.5 to negative 2 to negative 1.5 to negative 1. We are adding 0.5. That's our change in y values. The change in x value, we're going from negative 2 to 0 to 2 to 4. We are adding 2. So our slope will be the change in y over the change in x. So that will be 0.5 over 2, which can be rewritten as 1/4. So we're comparing 1/2 to 1/4. 1/2 is greater than 1/4, so statement 1 is true. The slope of function w is greater than the slope of function z because 1/2 is greater than 1/4. Now let's look at the second statement. The second statement reads that the y-intercept of function w is equal to the y-intercept of function z. So let's calculate the y-intercept of both and compare them. On a graph, the y-intercept is the point on the line that crosses the y-axis. If I follow my y-axis down, I cross the line at this point here, which is 0, -1. So y equals -1 is that y-intercept. Now here in a table, the y-intercept is the y value where x equals 0. So we have x equals 0 in our table, and the y value is -2. So y equals -2 is going to be that y-intercept. So the statement that the y-intercept of function w is equal to the y-intercept of function z is false. They're not equal. One is -1 and one is -2. So that statement is not true. Finally, let's look at statement 3. Statement 3 says that the y value when x equals -4 for function w is equal to the y value when x equals -4 for function z. So let's determine what is the y value when x equals -4 for both functions and see if they are equal or not. So the y value, when I'm trying to find the y value when x equals a number for a graph, I'm going to first look at that x value on the x-axis. So we're looking, where does x equal -4? That would be here. And very similar to where the y-intercept was when x equals 0, we now want to see where does that line intersect that x equals -4 line. Well, it intersects here. So that is the ordered pair of -4, -3. So y equals -3 when x equals -4 because that is the ordered pair on our graph, on that line. Now in a table, we have to see where the x value is -4. Now unfortunately in this table, we don't see that right away. Our lowest x value is -2. But if you look, it's really close. It would be one value before -2. If we could go backwards, we can see that y value. Well, we can go backwards if we do the opposite in the change in x and the change in y's as if we were going forwards in the table. So moving forwards, and we saw it with our rate of change or our slope, with the x values we were adding 2. So let's subtract 2, and that gives us that -4 value. I'm going to write it over here. So this would be x equals -4 by subtracting 2. Now, from going from negative 2.5 to negative 2 to negative 1.5 to negative 1, we were adding 0.5. So we need to subtract 0.5 to get a y value. If we subtract negative 2.5 minus 0.5, that gives us a y value of negative 3. So the y value will be negative 3 when x equals negative 4 for the table. It was also negative 3 when it was x equals negative 4 in the graph, so that makes the third statement true. That makes statements 1 and 3 true, which makes our answer choice B.